Did you know that the gold in your jewelry likely came from a supernova explosion? Yes, you heard it right. Supernovas, the explosive deaths of massive stars, are cosmic alchemists, creating and dispersing elements across the universe. In the grand tapestry of the cosmos, supernovas stand out as some of the most dramatic events. These are not just celestial fireworks for us to marvel at. They are the final act in the life of a massive star, a cataclysmic explosion that outshines entire galaxies and can be observed from billions of light years away. Supernovas are powerful factories, churning out elements heavier than iron. The gold on your finger, the silver in your coins, even the calcium in your bones, all likely forged in the heart of these stellar explosions. They scatter these elements across the cosmos, seeding the universe with the building blocks of new stars, planets, and eventually, life itself. Today, we are taking you on a journey from the birth to the explosive death of a star. It all starts in a cloud of dust and gas, a nebula. From this cosmic nursery, stars are born. Imagine a place where the elements of the universe gather, a vast swirling cloud of gas and dust known as a nebula. Within these cosmic cradles, the process of starbirth begins. The nebula's particles are drawn together by the irresistible pull of gravity, giving rise to a protostar, a baby star, if you will. Now, this protostar isn't quite a star yet. It's more of a lump of gas and dust, but it has potential. As it continues to gather more material, the pressure at its core begins to rise. And with this increasing pressure, the protostar's temperature also climbs, setting the stage for a spectacular transformation. When the core temperature reaches a scorching 10 million degrees, a process known as nuclear fusion ignites. This is the heart of a star, the powerhouse that fuels its brilliant glow. Hydrogen atoms, under extreme heat and pressure, collide and fuse into helium. This fusion process releases an incredible amount of energy in the form of light and heat, causing the protostar to shine brightly. And so, our star is born. From a simple clump of cosmic dust and gas to a radiant celestial body, lighting up the cosmos with its glow. But this is just the beginning of our star's journey. As it continues to shine, our star enters a phase of stability known as the main sequence stage. This is the prime of its life, where it spends most of its existence. The star now maintains a delicate equilibrium. The outward push of energy from nuclear fusion is balanced by the inward pull of gravity. This cosmic tug-of-war keeps the star stable, allowing it to shine for millions, even billions of years. And yet, even in the midst of this stability, the star continues to change. It burns through its fuel, fusing hydrogen into helium, and then helium into heavier elements. Now that our star is mature, it begins a precarious balancing act between gravity pulling in and nuclear fusion pushing out. A star's life is a constant battle against gravity. The star's fate depends on this epic struggle. This struggle, dear listeners, is an intricate ballet of cosmic forces, with gravity playing the lead role. As soon as a star is born, it begins a nuclear fusion process, the core of its existence, where hydrogen atoms are compressed under extreme heat and pressure to form helium. This process releases an enormous amount of energy, causing the star to shine brightly. This energy also creates an outward pressure, counteracting the incessant pull of gravity trying to collapse the star. It's a delicate balancing act, a state of equilibrium that defines the star's existence. Yet this equilibrium is not static. Over millions and billions of years, the hydrogen at the star's core gradually depletes. As the hydrogen fuel runs low, the star begins to fuse helium into heavier elements, such as carbon and oxygen. This shift marks a new phase in the star's life, often causing it to expand and become a red giant. Now here's where things get interesting. The lifespan of a star is largely determined by its mass. The larger the star, the shorter its life. You see, larger stars burn through their nuclear fuel at a much faster rate than their smaller counterparts. A star with a mass 20 times that of our Sun might live only a few million years, whereas a star the size of our Sun can continue burning for around 10 billion years. So in this cosmic dance, size truly matters. The more massive the star, the quicker it exhausts its nuclear fuel, and the more gravity gains the upper hand. Eventually, even stars meet their end. The heavier they are, the more dramatic their demise. But that, dear listeners, is a tale for another scene. A tale of supernovas and the explosive deaths of massive stars. For now, Let's marvel at the intricate ballet of forces that keep these celestial bodies shining, a testament to the incredible power and resilience of stars. When a massive star exhausts its nuclear fuel, it's time for the final act, a supernova explosion. This is the grand finale in the life of a star, where it takes center stage in the cosmic theater, putting on a display so dazzling it can outshine an entire galaxy. The process that leads to this spectacular event begins when the star's nuclear fuel runs dry. Without this nuclear fuel, the star can no longer generate the heat and pressure needed to combat the force of its own gravity. The delicate balance that sustained it throughout its life is shattered, and the star begins to collapse. It's like the ultimate game of cosmic Jenga. Once you remove the critical piece, the rest comes tumbling down. The core of the star collapses first, shrinking to a fraction of its original size in a matter of seconds. This sudden contraction sends shockwaves rippling through the outer layers of the star. Imagine a stone being dropped into a still pond, the ripples spreading out across the water. Only in this case, the ripples are waves of unimaginable energy, and the pond is the fabric of space itself. These shockwaves travel through the star, heating and compressing the gas in their path. The outer layers of the star are pushed outwards, away from the core at incredible speeds. This is the start of the supernova explosion. The star, once a beacon of stability, is now a maelstrom of chaos. Its outer layers are thrown off into space, forming a nebula of gas and dust. Within this nebula, new stars and planets will one day form, a testament to the cycle of life and death in the cosmos. Back at the core, the remaining matter is compressed into an ultra-dense remnant, a neutron star or a black hole, depending on the mass of the original star. This is all that remains of the star that was. In a blinding flash of energy, the star ends its life, outshining entire galaxies for a brief moment. This is the death throes of a star, a supernova explosion, one of the most powerful events in the universe. It's a fitting end to the life of a star, a cosmic spectacle that reminds us of the grandeur and mystery of the cosmos. In death, a star gives life. Supernovas are the universe's recycling program, forging and scattering elements across the cosmos. The death of a star is not an end, but a magnificent beginning. A supernova is the universe's grandest spectacle of transformation. In the heart of this celestial fireworks, atoms are crushed and reformed, giving birth to new elements. The energy of the explosion sends these newborn elements hurtling across the cosmos at incredible speeds. This cosmic ballet of destruction and creation is what makes life as we know it possible. Stars, in their death throes, become the alchemists of the cosmos. They take the simplest elements, hydrogen and helium, and transmute them into heavier elements like carbon, nitrogen, and oxygen, the building blocks of life. The supernova's explosive force is so great that even elements heavier than iron, which a star cannot produce in its lifetime, are formed. Gold, silver, uranium, and other precious elements are all born in the heart of these cosmic crucibles. But the work of these cosmic alchemists doesn't stop there. The elements, once forged, are flung out into the universe. They travel through space carried by the shock waves of the supernova. Over time, these elements coalesce, forming new stars and planets. Our own solar system, our own Earth, is the result of this cosmic recycling. The iron that courses through your veins, the calcium that strengthens your bones, the oxygen you breathe, all were once part of a star that exploded billions of years ago. So the next time you gaze up at the night sky, remember the supernovas. Remember the celestial alchemists that took the simplest of elements and forged them into the complex tapestry of our universe. From the gold in your ring to the calcium in your bones, you are stardust, made of elements forged in the heart of exploding stars. So, we've taken a journey from the birth of a star to its explosive death as a supernova. We've seen the grandeur of these celestial objects, from their humble beginnings in the nurturing cradle of a stellar nursery to their dramatic end as a supernova, a spectacle so powerful it can outshine an entire galaxy. We've learned how stars, through their life cycle, contribute to the cosmos, creating elements vital for the formation of planets and life itself. We've delved into the death throes of a star, a process that culminates in a supernova, where the star's core collapses, triggering an explosion of cosmic proportions. These cosmic alchemists, through their death, seed the universe with elements, shaping the cosmos and paving the way for the birth of new stars, creating a cycle of cosmic birth, death, and rebirth. Next time you look up at the night sky, remember, you're witnessing a cosmic drama of birth, death, and rebirth, played out across the eons.